Alright, so let's take a look at number 22 here. We're looking at page 201. Alright, so the height of an object dropped from the roof of an 8-story building is modeled by h of t. Alright, so here's our function. And notice that h is the height of the object in feet, and t is the seconds after the object is dropped. So how long before the object hits the ground? So we have this model here, and this object's being thrown, and we're trying to figure out how long, right? So this is our x-axis, this is our t, right? Because we're looking at time here, and then this is our height, our y-axis. So they're asking us after how long will that object have hit the ground. So we want to know the time that has passed. So we want to know how long has it been since the object hits the ground. Well, notice if it hits the ground, we can see here that that h equals 0. So our goal here is to figure out after what amount of time, so we're looking for t, after what amount of time has passed that the height is 0. So we need to set our function h of t equal to 0, because we're trying to figure out after how long did the object stay in the air for before it hit the ground. So here's our setup. 0 equals negative 16t squared plus 64. Notice this is a quadratic, so make sure that when you solve this, that your answer, always go back to your domain, is between 0 and 2 seconds. So obviously if you get a negative answer, we can't have a negative time, so we're going to throw that answer out the door. Alright, so a little hint, you can use a quadratic formula, but I would probably just factor out a negative 16, and you could go ahead and do the rest. So whatever you're left with in there, you're going to set that equal to 0 and solve. Alright, so let's see what you guys come up with. Have fun.